Okay, so the ascending tracts had their day. Now it's time for the descending tracts to have theirs. And remember, descending tracts are transmitting information down the spinal cord. So basically, from areas of the cortex or brainstem to the spinal cord and then out to some effector like skeletal muscles. And this happens to be an example of a corticospinal pathway shown here. Begins in the cortex. The pathway will go down, it will cross over. We'll talk about that more later in another chapter. It will cross over to the opposite side of the spinal cord. That's why the left side of the brain controls the right side of the body, right side of the brain controls the left side of the body. And then we'll proceed on, and here you will have the exit. Now, this neuron that goes from the cortex all the way down here to the spinal cord is called the upper motor neuron. All motor descending pathways have at least two neurons involved in the pathway. And the first is this upper motor neuron that begins again, probably in the cortex, but maybe also in the brainstem. This lower motor neuron way down here is still within the CNS, but will eventually deliver the information to the effector. The first of the tracts we're going to talk about is the one we just saw an example of, and that's the corticospinal tracts. And their job is to take and disseminate information about finely coordinated movements by your limbs. So being able to grasp a paintbrush, something incredibly fine and detailed is conveyed along these pathways, the corticospinal pathways. This one and this one. It's not necessary you understand there's an anterior and lateral, just know what the corticospinal tract does. And it has the conventional arrangement of upper motor neuron to lower motor neuron, and that's why it's named corticospinal. The naming convention is the same as we saw previously for the ascending tracts. The prefix tells you where it starts at, which in this case is the cortex, and the spinal tells you where this tract ends, which is the spinal cord. There are a couple other, let's say three other descending tracts of interest. The first is the tectospinal tract. So it begins in the tectum and ends in the spine. And the tectum is a region in the midbrain. It is where the startle reflex is accommodated. And so this is going to evaluate the reflex turning of the head to loud noises, bright flashes, and so forth. And so that's the tectospinal tract, this itty-bitty little part right there. Then we have the reticulospinal tract, part of it right there, another part right there. And this part has to do with several things. Posture will help with balance. It also has a fascinating interaction with pain pathways in that it can actually reduce the magnitude of the response sent by ascending pain pathways. And when you reduce pain, that's called analgesia. So that can happen with this reticulospinal tract. And then finally, the last of the major descending tracts is the vestibulospinal tract. And when you think vestibular, as you'll soon learn in chapter 14, it's all about balance. And so this is going to help us maintain our balance by all the inputs we get regarding that information. And so it's found right here in these two particular areas. So summary-wise, for testing purposes, corticospinal is finely coordinated limb movements. Tectospinal is all about the movement of the head and body so that you don't fall down in reaction to bright flashes or loud bangs. The reticulospinal tract is mainly for posture, but also has roles in reduction of pain. And vestibulospinal is for balance control.